Okay, today we are doing 2.3 notes. We're going to be focusing on how can you find a unit rate in description, an equation, a table, or a graph. So up here at the top, we have some vocab. Unit rate. A rate in which the second number, usually written as the denominator, is 1. So we can compare our miles per hour, cost per pizza. We kind of worked on that yesterday, didn't we, with the Howdy's Pizza? And then cost per pound. So if we're going to like a fish market or we're going to the store to get some meat, well, they usually do however many pounds it is. The cost is being altered. The cost is being altered because of the pounds. So, like they said, our second number usually written as the denominator. So miles over hour, or cost over pizza. It'd be written like this. Our constant of proportionality, the constant ratio of two proportional quantities, x and y, usually written as y equals kx, where k is the constant. For example, in the equation y equals 34x, the constant of the proportionality is 34. Our constant is always that number that's before our x. So we just found out that our constant is 34. It's always that number that's before our k or before our x. K is the constant. So right here, y equals kx represents a proportionality relationship. Here's our formula that we would use. K equals the constant of the proportion. Our y is the dependent variable. That is the dependent. And x is the independent variable. Bless you. So we should write down, make sure you're writing down what your k, x, and y's represent of the proportion. So when we graph, we want to remember that your y-axis is your vertical axis. That's right over here. Oh no, there it goes. Your y-axis is your vertical axis. Your x-axis is your horizontal axis. I always remember that the y has a little tail. It's nice and long. Y. There's our y-axis. An ordered pair is written as x, comma, y. When I say what is the coordinates of this or something like that, it's always written as x, comma, y, whatever those coordinates are, whatever that dot is on your graph. Okay? So we looked at this yesterday. It says in problem 2.2, we wrote an equation for the total price, P, for any number of pizzas, N, for Howdy's Pizza. Well, we found yesterday that the formula, the equation to find how many pizzas and the profit of it, we're going to do the profit, P, equals 13 times N, because we found that $13 is the price of one pizza. So we're going to answer these questions based on this equation that we found yesterday. What is the constant of the proportionality? Now that we have found the information of our y, x, and our k, oh, it's not in here. What is our, Eliana? What is our constant, which is our k? So remember, in an equation like this, y equals kx, our k is our constant. So if we're looking at this equation, what is our constant? 13, our number 13. That is our constant. Thank you. What is the cost of one pizza? Kind of already said this, and we calculated this yesterday. But Joey, what is our pizza? $13 for one pizza. Exactly. Is there an example of unit rates? So now that we know what our unit rates are, we found some examples up here. miles per hour, cost per pizza, cost per pounds. Well, now that we go down here and we're working with our pizza from Howdy's, is there really a unit rate in this, Sal? Oh, Sal's not in here either. Sophia? Yes? What is our unit rate? Yes, because it is the price or cost per pizza. Exactly. Per one pizza. So as we go on, Gus wants to determine which store has better prices for groceries. So he found these advertisements. Maybe he got them in a magazine or sent home. These are the magazines that he got for 2 different grocery stores. At which store should Gus buy pizza? Well, let's look at the information that or should buy pasta. I'm still on pizza. What store should he buy pasta? Well, let's look at these advertisements and see the deals that they say. They say pasta, 7 boxes for $6. And then this one says pasta, 6 boxes for $5. Well, we want to find the cheaper one because we're going to want to go to that store that's going to give us more pasta for the cheaper price. So I'll give you a minute with your shoulder partner to look and talk about which one we should go to and why. Okay, we're coming back together now. Let's come back together. Delano, you wanted to share with us which one we should go with? Okay.
So, what we did was we took 7 boxes, and then divided it by how many dollars it was. We did 7 divided by 6 and got 1.16 eating.
Oops.
And then
Okay.
we did the same thing for the fresh foods grocery store. We took
Right here.
6 boxes and we divided by 5 and we got 1.2. So we decided you should go to the more for your money grocery store because the how much you get for the amount per box is cheaper than the one fresh food grocery store.
Okay. So let's look at it like this. You're on the right track. Our fresh foods is which one is it? This one on the right. 6 boxes. What is it? $5? For $5. Let's write it the other way. Let's put our money on the top, just like they did up there. $5. So on the bottom is our pizza, our boxes of pasta. I'm still on my pizza. I must be hungry. And then over here for our grocery store, they have $6 for 7 boxes. Well, if we were to divide those, this gives us 0.857, so we can round that to about 86 cents. Okay, well, let's look at fresh foods. 5 divided by 6, about 8.3 repeating, so about 83 cents. Well, which one is cheaper? When we divide it like this, it's giving us the cost per box. So each box is going to cost us 83 cents. Each box is going to cost us 86 cents. Okay, so now that we know what each box costs, which one is cheaper, Lily? Fresh foods. Because each box is 83 cents. The other store is 86 cents per box. So in part A, it says fresh food has oranges on sale. At 10 oranges for $2. For each part, find the unit rate. Be sure to label your answer with the proper units. Well, what is the cost per oranges? We just did that for boxes per pasta. So with your face partners now, the people across from you, so that's 1 and 3 and 2 and 4, determine how much each orange is. And once you do that, you can go on to question 2 where it says, how many oranges can you buy for $1? Well, once we find what the price of 1 orange is, we can figure out how many oranges we can buy if we only had $1. Let's come back together. Let's come back together. So, how could we write this proportion? Let's see. Let's see if, Isabel, how could I write this proportion? I know that $2 is for 10 oranges, and I want to find how many, or what's the price of 1 orange?
Okay, so you want to do $2 divided by 10.
2 divided by 10, and that would equal our,
2 or 20.
right? Can we do a proportion like this?
Yes.
And so what'd you say? You said you got 20 cents?
Yeah, or 0.2.
Okay, exactly. So 0.2, we can do 2 divided by our 10. Or if we wanted to cross multiply this, we could do 2 times 1 and the same thing divided by our 10. So the cost of 1 orange equals 20 cents. Well, now that I know that 1 orange equals 20 cents, how many oranges can we buy if we only had $1? Let me see. 20 cents for 1 orange. Sal, how many can I buy for $1? 5 oranges. So we have our, let's see, 20 cents is 1 orange. Well, if we check this, 5 oranges would equal our $1, like Sal said for us. 5 oranges. Thank you, Sal. Okay, so if we go on to our next page, they gave us part of, guys, let's come back together. Eyes up here, side conversations. So we found already on that last page that for $1, how many oranges did we have? What was it again? 5. And we also found, Mason, we also found that 1 orange was how many? Or was how much, not how many. 20 cents. Exactly. So if we want to find how much 20 oranges are, how could we find that? Like, how much money could we find? We know that 1 orange equals 20 cents. Well, what is 20 oranges? How could we calculate that? Four. How did you get that?
Multiply 20 cents by 20.
Yeah, exactly. 20 cents, which equals 1. You can multiply that by 20 to get 4. So what if we had 11 oranges? What would the price be, Sam? 11 oranges. $2.20 for 11 oranges. Well, now they tell us that our price is $2.60. They don't tell us how many oranges. We have to calculate that. What could we do to calculate that, Zane?
Compute the 10 oranges and then add the 3
You could do that. You could do 13. So it's 13. You could take your 260 and divide it by our 20 cents. Is that what you were going to do, Mason? 260 divided by our 20 cents, which is the price of one orange, and that would give us our 13. So now that we know this equation, or this table, let's go on to our question 4. It says, how does knowing a unit rate help you answer the following questions? How many oranges can you buy for $5? How many oranges? For $5, how many oranges can we buy? Well, we did that over here for our 13 oranges. How do we calculate that, Ava Demers? Divide this by 0.2, and you would get what? Yeah. So $5 divided by 0.2, because the price of one orange again is 20 cents, that would give us 25 oranges. How much does 25 oranges cost? Now we know we have 25 oranges. And we need to figure out the price of the total. Stephanie. We have 25 oranges. We know that one orange costs 20 cents. So how would you calculate that? I'm sorry? How did you get that? In the top one?
It's like the top one, number 4.
Up here? Oh, so you just looked at that because it's the opposite. Yeah. What we could do is 25 oranges, and we can multiply that by what one orange costs to give us our $5, or exactly what Stephanie says in this first bullet under 4. It's just the opposite. But that's how we can calculate it. Multiply that by what one orange costs to figure out the total cost of 25.
So for the first bullet point,
Yep.
I did 5 times 5 equals 25. And so if you have 5 oranges, that's $1. So
Yeah, you can do it that way. So she saw that 5 oranges cost $1. So she just did 5 times 5 to get 25, since we know that 5 oranges cost $1 already. That's another way to do it. There's a couple different ways for these. So going on to 5, use the table that we created at the top of this page to help you write an equation that relates to the cost, which is represented as C, to the number of oranges, which is represented as N. Robert, how could we write this?
N equals 0.20 times cost.
Well, our 0.2 would be our cost. So with a shoulder partner, talk through how we could find the price. How we could find this. Write an equation that relates to cost, which is our C. So they tell us already that N equals blank times C. I'll give you about a minute. So going on to E, now that we were able to find our unit rates for these equations, the cost per orange and the number of oranges per dollar, and in D, we were able to find the information that the unit rates give us, which our info that Robert just said is our 20 cents per orange and our 5 cents per dollar. That table up above was able to give us this information. E, how does the constant of the proportionality relate to the unit rate? What is our constant? How does that relate, Ashley? Well, what's our unit rate again? Ashley, look up here on D. What did we say our unit rate? What's the information that they told us? Cost per orange. And what else? The number of oranges per dollar. So we were able to see every 20 cents is one orange, right? That's the constant. Our constant is 20 cents. Same thing here. Well, for 5 oranges, that's $1. That is our constant. So the constant of proportionality is the same as unit rate. Our constant is the same as our unit rate that we found. For 6a, graph the equation from number 5 on the 2 coordinate planes. Show the values of n from 1 to 20. So if we go on to our next page, is everyone done writing this down? Yes? Okay. This is our, let me write it on the side, number of oranges. Okay? And I'm going to go up by 2s. So here's 2, 4, 6, 8, 10, 12. 24. Okay, and on the bottom, this is our cost. It needs the currency. Cost, which is dollars. 2, 3, 4. Okay. There's our table. Now let's plot some points. We know that $1 is how many oranges? What did we say? Let's look back at that table. That table that we made at the top of the second page is going to help us. Aiden, what is $1? How many oranges do we have? 5. So I'm going to put a dot there for that. At $2, how many oranges would we have? Those on here. Peyton? I'm sorry? 10. So $2 we have 10. 3. $3. How many oranges would we have? Ava Mustang. 15. 3. Okay. And the last one, let's do 2 more. 4 and 5. $4 is how many? Oh no. $4 is how many? How many oranges? I'm sorry? 20 oranges. Yes. Thank you. And last one, 5. Not here. 5. Gracie, what is our 5 oranges? $5 is how many oranges? I'm sorry? 25. Thank you. Put right up there. So now, let me experiment with this. Get green. If I draw, let's see how nice I can get this line. Oops, I put my green dot in the wrong spot. That's why 2 should be here. Okay, so there's our line. If I go over here, I can do the same thing. Let's do cost. along our y-axis and the number of oranges down here. Okay, and we'll do 2, 4, 8, 10, 12, 14, 18, 20, 22. Everyone has this graph written? Okay, so let's plot these same things. We said 1 orange is 5. We said that 2 oranges is 10. 3 oranges is, let's do this. The cost of 1 so that's where my line is. How can you use the graphs to find the unit rates? How can we use our graphs to find the unit rates that we found in our tables? Well, our unit rates can be found at what point in our graph? Gracie? Our unit rates in our graph. How can we find it? Well, if we put it in our coordinates, x, y, this is what we want it in, we can find our unit rate, right? Would be, and what our y is. Our x. So how can you see the graphs to find the constant proportionality? What did we say? Who said before what our constant proportionality is? An E. Someone over here. Was it Eliana? Did you say the constant before? For E? What did we say it was? In our unit rates, we saw that they were the same, didn't we? The unit rate constant of proportionality were the same. So since they were the same, our unit rate in our graph will also be the same. It would be found at point 1y, which is what we stated up here was our unit rate. It's going to be constant still. Okay, and part B. Natalie's car uses 20 gallons of gasoline to go 600 miles. Write 2 unit rates relating to the number of miles Natalie drives and the number of gallons her car uses. Show your work and explain the reasoning. Unit rate for gallons per mile. So, she told us that 20 gallons gives her 600 miles. Well, what is the unit rate per mile? For 1 mile. And we want to find the unit rate for the gallons. Well, I just wrote our proportion. So, Anthony Coleman.
I got 30 gallon. Wait. 1 gallon. Every 1 gallon, you get 30 miles.
30 miles? Try it again. Let's do our cross multiply. If I cross these off, 20 times 1 gives me 20. And then if I divide that by our 600, what do I get? Point 0.03 gallons per mile. It's getting smaller here. We do 20 divided by our 30, or by our 600 to get 0.03. So if the unit rate goes from miles to gallons now, our proportion that Anthony found was 600. This is what we would do. So then, Anthony, what would we get?
30.
We'd get 30. It was flipped around before, wasn't it? What does each unit rate mean? What does the unit rate mean, Robert? Yeah, which what did we say it was? Based on those two. Sorry? Yep. So 0.03 gallons per mile means you get 0.03 gallons for every mile. And the same thing with our second one. 30 miles per gallon means you get 30 miles on 1 gallon of gas. That's what it means by 30 miles per gallon, per 1 gallon. On this back page, they graphed this for us. They made a graph. We don't have to put it in this time. It says the graph below shows the relationship between the distance D, it's represented as D, and the gallons G of gasoline. Which unit rate appears on this graph? Well, what's it going up by? What unit rate appears? This is our distance. For 1 mile, it goes up by what, Robert? It goes up 30. It goes from 0 gallons to 30 gallons. So then, Owen, what does it go up? Phil's not here. Rebecca, what does it go up by? From our 1 gallon to our 2 gallons? 30. So our unit rate, the graph shows that our unit rate is 30 miles per gallon. The points 130, which Robert said to us, is why we know the unit rate. Three, what equation relating D and G goes to the graph represented? Well, D is our distance. What equation could we come up with, Becky, to find our distance? Now that we know our unit rate, which happens to be the same as our constant, what equation can we come up with to compare our distance in our gallons? Yep. We know our unit rate is 30 miles per gallon. For this equation in 3, I already gave you what D equals. Now we need to figure out where we could put our G into our equation. Remember, we always want it in Y equals KX. Well, my Y is my D. What's my constant? 30. And then my X is my G. Thank you. So that's our equation we write. We were able to find that because we knew what our unit rate was at 130. For 4, which coordinate pair represents how far Natalie can drive on 1 gallon of gas and on 0 gallons? Well, she has 1 gallon of gas, how far can she get? 30 miles, okay. So we can write 1 gallon, that's our x-axis. So we have to put it in our xy coordinates. And then when she's at 0 gallons of gas, which is my x, what is she at for distance? 0. Thank you. Questions? Yeah, so if we're at 0 gallons of gas right here, what is our distance at? When we look at this table, they're both at 0. That's where we get the 0, 0 from. So if we go on, we have about 5 minutes, so let's get through this last question. Josh uses the proportion right here. He created it for us. 600 over 20 equals x over 4. To find the number of miles Natalie's car can travel on 4 gallons of gas, Lisa says she can use the unit rate. Do you agree with Josh or with Lisa? Are they correct or are they not? How can we find this? What could we do, Lily?
Multiply Josh.
Okay, we can cross multiply it.
See if it is the right thing to do.
Okay, so when we cross multiply that, is that true?
Well, you can use 600 times 4, and then we could do 2,400 divided by 20, which equals 120.
Which equals 120, which is our x, which really is our miles, right? So when he says we can use this to find the number of miles the car can go on 4 gallons of gas, well, can we?
Yeah.
Lily just told us we can cross multiply 600 times 4, and we can divide that by 20 to give us what our number of miles is. So yes. Well, what about Lisa? Lisa says she can use the unit rate. Can we use our unit rate? We can use this equation. So we can find that using this constant rate equation that Lisa wants to use our unit rate, well, that's our K. We can find that she is correct also. Josh can use the proportions, which he did up here. Proportions. And what's the other one? Lisa can use her unit rate. Both can work for them. Well, B, what other strategies can you find the number of miles Natalie's car can travel on 4 gallons of gas? Well, look at your graph that they gave us at the top of the page and talk with your shoulder partner for about a minute to determine that. So, what can we find based on this graph? We can see that the graph, if we look at point 4 and where our y is, the gallon is your x-axis, which is on the graph the point 4, and we found that the other one was 120 by looking at our table. So for a summary of these notes, you can compare unit rates to determine which one is better to buy. The constant rate is the same as the unit rate. There are always 2 different unit rates for a situation. You can determine which unit rate is more helpful. The unit rate is also found on a graph at the points 1, y. The unit rate is found in a table when one of the quantities values is at 1. Your equation is written in the form y equals kx. K is your constant of proportionality as well as your unit rate. The K is both the same, the constant and your unit rate. If a relationship is proportion, the equation can be written in the form y equals kx. The graph will pass through our points 0, 0, and you can find the unit rate and the useful unit rate to set up a proportion. So, with this being said, our homework is page 53, numbers 9 through 10 and 12 through 13, and there is a worksheet on page 52. So our worksheet 52, and this will be due tomorrow.